Welcome! In this video we will cover the querying of the dataset created in the previous videos and also the creation of a thread-based function in the PowerBasic Console Compiler. Sequentially querying the dataset would involve running the first query and then waiting for it to complete, and then running the second query. If there are a large number of queries to run, or the time taken to obtain the results of a query are long, then the total time to complete all operations can be longer than you wish to wait. So an alternative is to run both queries concurrently. This can be achieved by the creation of threaded functions that, once started, will run independently of the main processing. The main processing can then wait for each thread to finish the task it has been assigned. When launching many threads, you are taking advantage of the ability of Windows to multitask and spread the processing load across the entire system. To query our dataset, we're creating a brand new program today called Data Search by Thread, which is going to be a standard executable with all our variables dimensioned. We're including one of the include files that it ships with PowerBasic called Win32 API, which is going to be used because there are a couple of functions within this API we'll use later on in the program. We've also created a global array to hold our record set, and we're including the file handling routines we prepared in a previous video. The text file, the one which will contain our 9,000 data records, which is one which was generated earlier. Now, the main program at the moment takes that flat text file, loads it into an array, and then reports how many records it successfully loaded or not. If we ran this program now, it would say it had successfully read 9,000 records into the array. So, what we want to do, having read those 9,000 records into the array, we want to do some queries on it. Now, in order to query this successfully, we're going to break up our query into a user-defined type. So what we're going to do is we're going to create a user-defined type at the top of our program, which is going to have a number of elements in it. It's going to contain a thread handle, which I'll explain shortly. It's going to contain the start element in the array we want to start at, the end element of the array we want to finish at, the column we're interested in querying, and the criteria that we're searching for within that column. So, what we need to do is we need to actually set the values of these. So in here, I'm going to use the prefix command, which we've used before. And this prefix command is going to use this user-defined type. Now we're going to define two user-defined types because we're going to query two separate pieces of information within our data set. So I've created the search criteria 1 and search criteria 2 based on this user-defined type we've just defined. And the first query is going to look for the first element to the end element of the array. It's going to look in column 5 and it's specifically looking for the value blue. This is iColor. Now, in order to query that, we will put a call into a function, and we will call this function readArray. Now, we want to create a threaded function. Now, this is different to a normal function in that it can be concurrently launched. So, we use the thread create command. The thread create command is used to call a predefined function with one numeric parameter. And you can also store the thread handle in an array. Now, we'll need to dimension that array in order that we can actually pick it up. And as well as dimensioning the array, I want to store what the current status of that particular thread is. So we'll create two arrays. The first one to contain the thread handle. Now we're only going to be launching two threads here, which is quite a small array, and one to contain the status of the thread that you've just launched. In other words, is the thread still running or has it completed its task? So, since a thread function can only accept one parameter, what we're doing here is we're passing the pointer to where this memory structure actually exists. So we're using byval, so we're passing a value, we're passing the pointer to where that particular variable resides in memory. So that would be the call to our first query. Using the thread create before the name of your function means that you're going to launch that function as a threaded function. You are then going to, as soon as you've launched that function, continue on with the next line of code. You're not going to wait for the function to actually complete. So we're going to take advantage of that, and we're going to set up and populate our second user-defined type for the second query we're going to running. And this is going to be looking in column 6, which is the one that contains the blood groups, and it's going to be looking for this value in that column. And we will then read the data again from the array using our function, which we will create in a moment. And this one is passing a pointer to the second user-defined type and storing the value of the thread in the second element of the thread array. Now, as you have probably noticed by now, we have launched one threaded function which will run away in the background. We have populated a second set of criteria and called a second function. Now if we did nothing else, the program would reach this point and it would go straight to the end of the program. Now that's not what we want to do. We want to wait until both of the threaded functions have actually completed their work. So what we need to do, we need to create a test to see whether the threaded functions have actually completed or not. So I've created another variable called the total thread count. How many threads do we actually launch, in which case is 2. I'm then going to populate that into a function which is going to test whether we've waited long enough for the threads to actually finish. It's going to test for the completion of each of the threads, and it will stay inside this function until such times as both of the threads have actually completed. And at the end of that, our program can finish. Now, we still have two functions to create then. We've got the one that reads the array and the one that waits for the threads. So let's look at the one that's going to read the array first. Now, this is a read array function. Now, unlike ordinary functions, it's preceded with the word thread, so that the system knows it is a thread function. It is actually taking in a value, but what we're taking in here is a pointer variable. This is basically a pointer to where the user-defined type structure exists in memory. Now, what we need to do to actually access that is we need to create a local variable as the user-defined type we're talking about. So it's going to create a brand new memory structure with that criteria, and we're going to copy the parameters from our past pointer into the local variable. So we will have a local user-defined type which has all the data we passed in. This is very efficient in that calling the threaded function only needs to pass a single memory pointer. Now, what we're going to do in here to actually do our search? Well, we'll need a couple of local variables to let us cycle through the array. So we'll create two, one as a counter and one as the element of the array. So this is going to be for the beginning of the array to the end. Now, TP is the name of our local user-defined type, and the starting parameter is the initial element we want to look at. So that is going to be our for next loop, and we want to actually test to see if the value we're looking for in the global array for the element we're actually querying. Now we know it's a tab delimited string, and we're looking for a specific column which was passed in the user-defined type. Now, since in user-defined type strings are actually of fixed length, we're actually using the trim command to trim the string down to strip off all the blanks at the end of the text, so they can do a true test. So if we do actually find this value, what we can do is increment the count. Now we're specifically interested in how many of that particular value, so when we're querying eye colour, if we're looking for the number of people with blue eyes, then we will return basically the number. So what we want to do then is we want to basically output to the console the value we've actually got. So we're saying whatever we were looking for, in this case blue, equals and the number that we actually found. So that completes our function to read the array. The tricky bit is actually knowing when each of the threads has actually completed. Now we created a wait for threads function. So our wait for threads function is going to take in several parameters. So we'll create our wait for threads function at the bottom. Now this basically takes in the number of threads to wait for, the array of the thread handles, and the start thread index. Now I'm just going to paste in all of the code that actually does this function, and then I'll explain what it actually does. Right, okay. There we have our function that waits for the threads. Now this is going to be a loop. We want the wait for threads function to sit in here and wait until all the threads we've actually kicked off actually complete. So it's using this Windows API call, which is why we included the Windows API include file called wait for multiple objects, and it's taking in the details that we've passed it, as in the thread to wait for, the thread handles, and it's returning from here a return value, and it will then check to see whether this return value is actually complete or not. And there are a number of different values we could get back from that. If the wait has been abandoned or timed out or failed. And what we're waiting for down here is for the thread to wait for. Once the thread to wait for is equal to 0, then there are no more threads to wait for, and it will be complete. Now, just in case Windows throws any errors, we've created a small function, this one here. Now this one again is calling some information from Windows to actually get the value of the system error message. And again, this is one of the reasons we wanted to actually have the Windows API calls in there. So if we've actually set this up correctly, and it has compiled, if we actually run this one now, what it will do is it will actually run. So it has brought back two values. It's brought back the value of the number of people with type B plus blood and the number of people with blue eyes. And it has successfully recognized that the total number of threads running is 0, therefore it has been completed. Now you'll notice that the first thread to complete was the one looking at the blood type, and the second one to complete was the one for the blue eyes. If we look at the way our code was actually called, we called the function to search for blue eyes first. So in this particular case, the second thread finished first. With threaded functions, depending on the load on each function, there's no guarantee that the threads will finish in any particular order. So your code's going to have to pick that up and handle it accordingly. Now, although we're throwing the value of the return from the thread functions out to the console, that's fine if you're sitting watching the program, but in normal circumstances you would want the value from a threaded function to go somewhere, perhaps into a database or into another structure. Since these are console applications, there is no dialogue for the users to watch, but the threaded functions do give you a way of actually doing many things concurrently within the same program. So I hope this has actually helped with understanding the way thread functions actually work. It's a wee bit intimidating for the knowing when they actually finish, but this generic routine is actually quite successful in determining when a thread actually finishes. So, thank you for watching.